Okay, so can you give like a 1-minute overview about like who you are, maybe what college you went to, how much LeetCode have you done, stuff like that, how much experience you have?
Sure. Yeah, I'm applying to new grad jobs. I went to like a tier 50 college in the US. Um, I've done nothing crazy for LeetCode. I've done about like 300. Um, and yeah.
Okay. Okay. So the first problem we're going to do is you're going to be given an array called n, and it's going to be one indexed. So for example, let's say you have this. So you're allowed to perform an operation, and I will write it. So for any index in this range, you can swap I and I times 2. So this is one indexed. Yeah, so basically you can swap, and you can do this as much as you want. And what I want to know is, can the array be sorted at the end? So does that make sense?
Okay.
Okay, so for example, here, you can actually swap, let's see, actually let me give you this test case instead. So you can swap, so this is 2 and this is 4, so you could swap those. So you would get 1, 2, 3, 4, 5, and this would be sorted. And if you had 1, 4, 2, 3, 5, this you could not do, because like you could swap like this or something, but you can't swap, you can't get the 2 over here. So essentially this would be a no. Okay, and yeah, feel free to ask anything you want to.
Okay, sure. So, are there any constraints on the input size? Like how big of an array can I work with?
Yeah, so I forgot to mention one thing. So your input will always be a permutation of n. Permutation of n. So like in this case, if n is 5, it's just like 1 through 5 or whatever. As far as size, you can just assume it'll fit in an integer, so like it can be pretty big.
Okay. So yeah, okay. So for the example you gave, you can just switch. So this would be index 1 and index 3. So
it's one indexed, so it'll be 2 and 4.
1. Okay. So hmm. Um, I mean my first reaction is maybe I could explore like a brute force solution where I can wait, actually 1 second.
Yeah, and I guess I already said this, but just to make this clear, so you can do this as much as you want.
Yeah. Okay. So yeah, I could explore all possible scenarios of um, swapping I and I times 2, um, and then checking whether that is um, equivalent to the sorted array. So essentially, I'm returning a boolean here, right? True or false?
Mm-hmm.
Yeah. So in terms of time complexity for that, that would be looking at um, so I don't think I would have to search through the entire array, because Oh, actually, maybe I could do like a two pointer approach, where if I have one pointer pointing to the front and one pointing to the end, and every time if the left pointer isn't less than the right pointer, I can swap them. And will I have duplicates also?
No, so you have a permutation, but you can't swap. For example, you can't swap these. So like the index has to be double. Well, like one of them has to be double the other. So this would be like 1 and 5, and you wouldn't be able to swap.
Yeah, you're right. Sorry. Oh, I see. So yeah, so I can yeah, so if I swap these, say 1 and 4, then I can put the one here, and then I can then swap the 1 and the 2, and then do like that. Like that's valid also.
Yeah.
So and then there I could also get the I could also move an element backwards too. So every element can either be be at its current element, or plus or minus a power of 2, I believe, because
well, like imagine this thing was like length 1,000,000. Like 6 would be able to swap with 12. Is that a power of 2?
Oh, sorry. So it would be no. So yeah, it could be swapped with 6 and then 12 and then 24 and then 48, and it could be at any of those. So no, sorry. 6. So it would be or current element, or sorry, current index multiplied by the power of 2. And this could be positive or minus also. Could be. Okay.
Okay.
So I guess for each element, I can kind of like, I can pre-compute the sorted version of the array, and then check whether say like I can find the or I can go like from left to right, right? Or sorry, if this is the input, I can find it in the sorted version and say like, okay, this is the 4th this is the fourth index here.
Mm-hmm.
If it is, if 4 is equal to the current index times a power of 2, then I know that it can be placed in that index. Does that make sense?
Yep. So one small thing there. So what would be the time complexity for this?
So finding the index of each number, in the worst case, would be O of n.
Mm-hmm.
If it would have to search through the end of the array, and then seeing if it would be in one of these possible spots. That would be capped at the 2 to the, that would be capped at 30 of 31, I believe. Or sorry, 32, if it's like
Okay.
if the length of this can be described by an integer.
So you said finding the index of every number is O of n. So why is that?
Because, for example, if I look at this 4,
Mm-hmm.
and then I see. Sorry. So yeah, if this is a permutation of n,
Mm-hmm.
that means, so the input we're given is numbers from 1 up to and including n,
Mm-hmm.
correct?
Mm-hmm.
So, yeah, so then we don't need to find it because we already know where it's supposed to be. So for example, the 4 should obviously be like the 4th position, right?
Mm-hmm.
And the second should be the second one.
Yeah.
So yeah.
Okay.
So in which case we would just be computing this right here
Mm-hmm.
each time for each number in the array. So that would be O of n.
Okay. Yeah. Yeah, I think that makes sense to me. Do you want to code it?
Yeah, sure.
Okay.
Okay. So I'll define a function called can swap into sorted. That takes in an array and would I be given n too, or would I just
Do you need
do I
it?
just get it from the length of array?
I mean, whatever. I don't think it matters. You can pick one.
Yeah. Okay. So I'll say that n is equal to the length of array. And then I want to so now I want to go through each element in the array. So I do a single pass through, or for each index. Sorry. Actually, I'm just gonna call this nums. It's just easier
Okay.
for like muscle memory.
Sure.
Okay. So now I want to check if so now I want to get the possible places that this could exist in. So let's see, how do I want to do this? So it would be I plus j to the power of 2. And then if I want to move it backwards, I'll subtract. And then if, so now I want to check if each number is in this possible, or sorry, I'll check if each number is not in that set. And then if I go through all of them, I can return true at the end. So if I not in turn false. Let me think if there's or let's see if there's any bugs in this really quick.
Okay.
Rechain. Oh, this is backwards. Okay. So okay, I think this would work.
Okay. Do you want to dry run the example?
Yeah.
Okay.
Yeah, I think there might be an optimization I could make here where I don't have to pre-compute this every time because the yeah, I think I wouldn't have to pre-compute this every time because I would know the numbers or know like exactly what it would be based off the index. But okay, yeah, I can do a dry run.
Yeah,
So
let's just dry run.
Yeah. So say for this example you gave me. So okay. So n would be equal to 5 and let's change that to n. So I would loop through each of these numbers and say for j in the range of 32, I would build this set of possible indices that this number could be swapped to.
Mm-hmm.
So for the 4, this is currently at index 1. And maybe okay, so then yeah, I look in here and I'm adding to the set. So in the set I would be building, I would have I would be at 0, so it would be oh, okay, yeah, I think I have a bug here. So because it's 1 indexed, I should be looping from 1 to, or no, there should be I plus 1 and let me just think how this would go. So yeah, I would want to add, if the original index is 1, I want to add, I would add then 2 to my set, and then 2 could be swapped with index 4. Wait, sorry, I'm kind of confusing myself. With this 1 indexing. So I think I had it right the first time, actually. So
Okay.
yeah. So if it's originally at 0, index 0, it could be swapped with index 1, because 0 plus, so it'd be like the things I'd be adding to I would be 1, 2, 4, 8, right? So all of these are possible.
So if you do it 0 indexed, this will be 0,
Yeah.
this will be 1, which would have been 1, 2, that's fine. But now your 4 will be here, and you can't swap these two.
Oh, I see.
Mm-hmm.
That makes sense. Okay, this is also a bug too. I shouldn't be looking at this. I should just be looking at oh no, this is right. Yeah, okay. So if I'm doing 1 index, so I want to grab let me just make this more clear to me. So iterating through all numbers, and then I'll say num is equal to nums of I, and then so the current index is going to be I plus 1. And then in here, I'm going to do so the current index plus, so this would be so now, okay, assuming for this test case, I start at a 4, right? My current index would be 1. And what I'm trying to see is if 1 can be swapped with index 4. So, and in this case, it can be. So the possible indexes it could be swapped with, it would be 1, and I'd be building these in the negative direction too, in the backwards direction too, but I'm just gonna skip that here since we know we're moving forward. So it would be 1, 2, and then that would be 2 to the 0, and then this would be 1 plus 2 to the 1 would be 3. So this this is wrong. Oh, this should just be multiplied.
Mm-hmm.
So okay, I think this is right now. Okay, so now we would have 1, 2, and then so or no, it'd be 1 would get added 1 times 1, and then 2, and then 4. Yeah, okay.
Mm-hmm.
Yeah, and then say for 2, current index would be 2. And then here I would add 2 for 2 for 8, and we know, or what? So yeah, so we know here 2 is in here, so this would pass. I could optimize later and say like, okay, if it's if we see the index we want, then we can stop this loop. We'll just go on for now. So 3, same thing. 3 is already in its right spot, and then 4. So 4, same thing as or sorry, not 4. I'm looking at the wrong row. So 1 here. I think this could also be optimized because we already know that 4 is valid. So by symmetry, we would know that this is valid also. But this would still work. So in the backward direction in our set, we would be adding 4, and then times oh, I see the bug. Okay, so here we would want to do, instead of Okay, so here, like this would go to -4 in the first scenario, which is completely wrong. So here what I want to be doing is moving backwards by that amount. So,
So I think we should just move on to the second problem to give you some time, because this is like some small thing.
yeah,
Accessibility.
sure.
Okay.
Yeah.
Okay. So in the second one, I don't know if you were the person who did this, so let me know. So have you done the sliding puzzle one?
Yeah, I actually did that today.
Okay, so let me do another one then. 1 second. Yeah, I'll give you a little bit more time.
Okay.
Okay, so I can do another one. So there's going to be another game one. So you're given a 3x3 grid.
Okay.
And the total of this grid is 9. But the number in every cell can be whatever you want as long as the total is 9. So for example, you can have something like this. So maybe like this. So the total here would be 9. Basically, what I want you to have the end is all ones, okay? And you can do one move as much as you want, which is take a 1 and move it left, up, right, or down. This costs like 1, and return the min you need to solve this. So basically here, this would just be 2 because you can just take a 1 here and move it here, and take a 1 here and move it here.
Okay, so when you say end is all ones, you mean this last row here?
No, so every single cell needs to be a 1 at the end. So you have a 3x3 grid. The entire total of the grid is 9.
Yeah.
And you need it to be all ones. So like 1, 1, 1, 1, 1, 1, 1, 1, 1.
Okay. And when you say we can move the 1 as much as we want, what exactly do you mean?
So imagine you have like marbles or whatever or something in a cell.
Yeah.
You can take one marble out of a cell and move it left, right, or up or down. One cell. So like I can take a 1 from here and move it here.
Okay.
Yeah.
Okay. Yeah, so here I'm thinking that so yeah, we can and will there always be a valid answer?
So what do you think? If there's 9 total, is there always a valid answer?
Oh, sorry. Yeah. Sorry, I thought you meant like it has to equal 9, but so yeah, so this will always add up to 9. Okay.
Mm-hmm.
So in that case, there's a finite set of answers we could explore. So I could basically just explore all possible game states of moving marbles around until I find the minimum it took to get ones in the entire grid. And the only thing I'm curious about now is actually, okay, never mind. So yeah, so I can kind of do this with like a BFS like approach where I can search through the grid, and if a number is already a 1, I can leave it. But if a number has more than 1, I can explore up, right, left, and down to um, to explore the different options of distributing those marbles to get 1 in every spot.
Mm-hmm.
Which I think that would work. I'm thinking though if there would be a fast way to do this. So like in this scenario, we could also just maybe it might be more efficient to look outwards from the zeros to
Mm-hmm.
find the closest cell that has more than 1.
Okay. And what if there's a tie? How do you know? Like, imagine we have this. Like here, it doesn't matter which one you pick, right?
Yeah. Um, that's a good point. Yeah. Because, yeah, if I take 1 from here and move it there,
Mm-hmm.
then it would take 2 more moves to get to fill this one.
I think actually in this case it wouldn't matter, but yeah, there are examples where it does. This case, like
Oh,
whichever
yeah,
one you
because it
pick,
can't be
it'll always be
diagonal.
2. Yeah,
Yeah.
but like if there was, I mean, the easy example is like this. Now it matters for sure. So like if here you pick the
Yeah.
closest and you pick this one, then it matters for sure.
Yeah. 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 Okay. Yeah. Yeah. So in that case, I could just um, explore all the different possibilities. Um, in which case, um, so there could be. I'm trying to think of the time complexity of that in the worst case. So, um,
So by all possibilities, do you mean like you'll just take something that's bigger than a 1, you'll like move 1 somewhere, and that's like a move?
yeah, yeah, I could.
I see.
Yeah, so I can basically yeah, keep moving it around until I put it in a valid spot, and I could store the um, current game state with the, or I could cache the current game state with the number of moves it took to get there. Also,
Okay, how would you cache the current game state?
so I could use a um. So what I would do is maybe I could also, yeah, maybe I could also make this one dimensional and cache it as a string.
Okay.
Um, yeah, and then
And you're basically just gonna like make 1 move like you're gonna pick like how are you gonna know what to move, I guess, as well, right? So like let's say you have this, how do you like move this and then later on like move the same thing or something, so you don't just like go forever, or maybe you do go forever, or I don't know, like yeah,
Um,
like what would you
yeah.
pick to move?
So I wouldn't. So I would have a. Um, well, it would be impossible to go forever if I was caching, because there's only there's a finite number of possible game states if um, it all adds up to 9, assuming
Do you know roughly how many game states that would be?
yeah. So we wouldn't have any negative numbers either, right?
No.
Yeah. So um, there would be. Hmm. So for every marble, I can put it in one of 9 places, and then the next marble I can also put in 9 places. So it
Mm-hmm.
would be um, 9 to the 9.
Okay, yeah, that sounds reasonable. Okay,
Yeah,
so basically you're gonna say like you'll,
which is kind of large actually. Yeah.
yeah, so how can we improve it a little bit at least? Like you're basically saying I'm gonna take a random number, like maybe this number, and I'll move
Hmm.
it, or this number, and I'll just move it in like one by one. How can we improve that to where we like reduce the game states a little bit? Like how can we make smart moves, I guess? Like would you ever want to move like something that has a one, for example?
Yeah, yeah, no. So I would never want to move something that has a 1.
Mm-hmm.
Um,
Is there anything else you can like speed up?
and then I would also hmm. Oh, another, I'm not sure if this would work, but another idea I had was um doing like a finding like the minimum distance from each 0 to um each cell that has greater than 1. So like forming like a so like from here to here, this would be um length 1, and then uh this would also actually I'm not sure how I would implement that.
Yeah, plus with that, like I think I already showed you that like you can't just take the closest because that's not always right. So how does that help you?
Yeah, well, I was kind of thinking like um hmm, actually no, yeah, never mind. Um
So I guess like you're taking a number that's bigger than one and you're moving it one. Like how can
yeah,
we do something better than that?
we can take the Oh, I see. Yeah. So instead of just moving everything one by one,
Mm-hmm.
we could make it faster by exploring the possibilities of just putting it in each zero space,
Mm-hmm.
where each zero space would be like the what's it called? The Manhattan distance, I think is what it's called. Like
Mm-hmm.
the horizontal and vertical moves to the zero. That would be how many moves you would need to make to put it there.
Yeah.
And then I could just explore each of those options instead of moving it one by one.
Mm-hmm. Yeah.
Um,
I think that makes sense. So do you want to try to code that?
yeah, sure.
Okay.
So okay. So I'm just gonna do it like explore all the options first, and then after I think um my
Okay.
function would work, I can cache or worry about caching after.
Sure.
So I'll define a DFS helper function that takes in the um the current it would. So I don't think I need to fasten the grid. So I can just backtrack from my moves, and I would definitely need the current number of moves at each state. So, and maybe I can also I want to traverse the grid beforehand and pre-compute the spots of all the zeros.
Okay.
So uh, let's do that also. Um, equals Actually, I think for caching, I could use um a Boolean array. So I'm thinking of how I want to store the zeros.
Mm-hmm.
Um, for now, I'll just use a set. So for every zero I find, I'll add a tuple of the coordinates.
Mm-hmm.
So okay. Um, so for my DFS, my base case is going to be that this zero set is empty. So
Okay.
So if it's empty, then I want to return the number of moves it took to get there. And then if it's not empty, then I want to try placing for yeah, because I also need to remember which cells have greater than one marble. So, I mean, I can actually just traverse the whole thing again, I think, because 9, looking at all 9 isn't that big of a deal.
Okay.
So now I want to see if this grid, if the value of this grid is greater than 1, then I want to, so in this case, I want to try redistributing marble. So for okay, I'll also just have a variable here to keep track of my my result. So
Okay.
I'll just initialize it to infinity.
Okay.
So then for each of these marbles, I want to try moving it to each 0. So so I'll decrement it, and then or not, sorry, for 0 and zeros. I want to fill it. So I want to add 1, and then I want to remove it from my set. So okay, and now I want to call DFS again to explore that game state. So then I would call DFS, or I would set, so res would be equal to the minimum of the current res, and DFS of moves plus 1. and then I would. This is giving me.
Okay, so we're
An
like a
error.
decent amount over now, so let's just stop and do feedback. I think we're like 10 minutes over.
Okay.
So, okay, so how do you think you did? What do you think you did well, and what do you think you need to improve in?
Okay. I think something I need to work on is like. I mean, I don't know about your opinion of multitasking, but for me, I kind of feel like it's like not real. It's like really hard for me to like have a clear train of thought, and also be typing out my solution at the same time.
Mm-hmm.
So yeah, I think that's something I kind of uh, don't do well in. Like I kind of think to myself like I should be talking through my solution,
Mm-hmm.
and like I want to keep talking, and I don't feel good about like taking more like pauses. And I think because of that, I was kind of like getting psyched out about like this first problem you gave me.
Mm-hmm.
And um yeah, I think like this kind of problem too, I don't have a lot of reps with. So
Mm-hmm.
yeah, I think maybe that's something I could work on is um instead of just talking for the sake of talking, um, like make sure I'm thinking correctly first and get more reps in.
Yeah, and I
Um,
think like I purposely tried to pick problems that people don't have a lot of reps in because I don't
yeah,
want to just give you something you've seen on the LeetCode 155 times and you're like, oh yeah, it's whatever, this thing, I'll just write it. I don't even have to think, you know? So
yeah, yeah,
so with these, like you can use things that you know, they're not super complicated, but you have to like think. So I get to see like how do you problem solve instead of how do you regurgitate something you've seen 50 times and like pretend you haven't seen it. And
yeah, yeah,
and I think a lot of people struggle with that for sure because it's like more, yeah, how do you problem solve instead of how do you memorize? So I think for the first one, so you basically took a very long time doing something that I would consider basic-ish, and you even
yeah,
recognized you were like, so I know where this is in the permutations, right? Like this is like at index 4,
yeah.
and you know where you're at. So maybe you're at index like 1 or whatever. Like all you really had to do was just check if like one is a multiple of the other times some factor of 2, right? So if you do like 4 over 1, you get 4, and 4 is a factor of 2. If it was the other way, you can do the same thing, and then you can like get it really quickly. So you would just, like 3 and 6, same thing. You would divide like 6 by 3, you get some factor of 2, and then you can do it. So you could have done this
Oh,
in like
okay.
O of 1, but either way, like I would have accepted this answer, but you took a very long time to figure out like, okay, so it's 1 index instead of 0. How does that change things? And then it's like, uh, and then how do I get like all these factors of 2, and how do I like go through them and stuff?
Yeah, yeah, and I think like yeah, even past that, um,
And I
I
think, yeah,
was
this was also still not correct at the end, like even with all
yeah,
that time.
yeah. I know there's a bug here, but even like while I was coding it up too, like while talking and stuff, I think it just gave me so many bugs.
Hmm.
Um, Yeah, so yeah, I also just need more reps with this kind of problem. And I knew
Hmm.
this was supposed to be easier too, but like the second problem you gave me was like a lot easier for me, or like thinking about it, and like I know I could have
So I feel like the
got
first one
through
was
it.
like a pretty, like I wasn't sure if it was like medium or too easy or whatever, but it was like pretty reasonable. And you actually came up with a very good solution. Like I did it a different way, which I mean, there's a bunch of ways, but I basically grouped all the things together. So I would say like I'll just group 1, 2, 4, and whatever into a group, and I'll sort all of that, and then I'll like put them back. And I did that with like a heap. But I think Euro is even better, where you were like, I can literally just check where this thing is. So I think you're like part of your problem solving is good, but then when it came down to like the actual implementation of like how do I get this thing, you really struggled. Um,
Yeah,
so it's like your high level problem solving. This is pretty common. A lot of people have like decent high level problem solving. They kind of know what they need to do, but then they don't really plan out the implementation. So I think another thing could have helped you is you could have been like, well, if I'm at index 1, how do I check if I can go here? You know, and
yeah,
you realize like, oh, I needed to multiply it by a power of 2, So I can just take like the big index, divide it by the small index, and then like this has to be a power of 2, and then basically done. So something like that would work. And but your thing is fine too. So like totally acceptable. But basically, yeah, you want to come down. You want to figure out a solution that you can code quickly that like isn't gonna hurt your brain. And you were like, I have to go forward, I have to go backward, I have to make sure the numbers are right. So if the solution is going to be a little bit tricky for you, come up with something simpler. And so yeah, like I said, basically what I did when I did this like yesterday or something is I would be like, okay, I'll put all these in one group, and then I'll sort them, or I'll put them in a heap, and then I'll just like for the first index, I'll just like pop them in, and then for the second index, I'll pop them in, and so on, and then I can just check if it's sorted at the end. So that's like one way to do it. It was like easier to code, I guess. I didn't think of your way, which I think, like I said, I think your way is better. I think your way is like you could do in like linear time and like basically 0, 1 space. But whatever you pick, you need to be able to like make progress. And I feel like you were like very slow in basic-ish stuff, because this is basically like 3 lines of code. I think you spent like 10 minutes here. So yeah. And then for the second one, yeah, so let me see what I wrote. Yeah, so adding is wrong, got an answer, took a very long time. And then let's see. Yeah, and then you can pretty easily check if you have a power of 2. I guess one way to do it is like you just have some number, you just keep dividing by 2 or something, and you have to get like 1 or 0. If that's the case, then yeah. Okay. So the other, let's see, yeah, the second problem, kind of the same thing. You were kind of like coming up with something, but you were taking a very, very long time figuring it out. So it's like reps just like need to get better at problem solving. Also, I guess for like some companies, like Google in particular, like I've seen people get asked things that are a little bit more math and like logic, then like I think they try pretty hard not to ask stuff that's like on a LeetCode list or something, where like for meta, like they pretty much ask you something that's on like 50 lists. They don't really care. So depending on the company, depending on what they do, I like the first approach where I don't like if something's on like 50 lists, like why would I check how well someone memorize something? Like I want to see if they can actually problem solve. But yeah, so for the second one, the BFS and caching made sense. So you were like, okay, well, how do I cache? And so the simplest solution that came to my mind, but I was like, I think BFS and caching works, is just backtracking. So you basically just find a number that's bigger than 1, and then you put in a 0, which is kind of what you were doing. But you said, I'll do a BFS, and then you ended up basically coding backtracking. But once again, it took a very long time. And then you need to try to figure out optimizations. Like, I don't, like, why would I put a 1 in a random spot? Like a 1 from something is going to go into a 0, so I can skip all that and put in a 0. And then it's basically like once you recognize that, it's like the things you have to recognize, like it's a pretty small grade, so like you can have something unoptimal. And then like what's the time complexity? Also, backtracking would be better. I think your BFS thing you said was like a 9 to the 9, which I agree, especially if you were just moving a 1 to random spots. Where backtracking would be like 9 factorial and realistically less, because you're basically moving a 1 into a 0. So for every 1, you can move it into 8 slots, I guess. So it'd be like 8 factorial or whatever. So it would be like significantly less, and realistically it would be like way less in like a real grid. And I think it would be like easier to code because you wouldn't have to cache. You'd literally, and you pointed out, like I can just loop through my matrix because it's tiny. So you can literally like loop through your matrix, find a 1, loop through your matrix, find a 0, and then just like, loop through your matrix, find a number that's bigger than 1, and then for all the zeros, just try to put it in those. And you never need to cache because you'll get all of the solutions will be different, and then you can just like add it up. Or get them in, sorry. And I think you were coding stuff, but some of it was still wrong. Like you recursed here. This isn't moves plus 1. This should be like the Manhattan distance, like you mentioned. And I was like, you're already like 5 to 10 minutes over. So I think the speed is like, you can be a little slow, but if you take way too long on, a couple lines, it's really going to kill you. Like I felt like after the first one, you'd have to have like a miraculous recovery to do well. And that's generally what happens. So for these like 2 problem type of things, like if you take a forever on the first one, you basically can't do well on the second one.
So like for the first one, like if that happens to me, should I be like clear and like ask for another hint, or should I just keep trying to like
I
think.
think you should plan it out before coding more. So in your coding, you should know how this needs to happen.
Yeah. I mean, that
So
was my issue. So,
yeah,
yeah,
go
sorry.
ahead.
No, I was gonna say, like, I feel like I did take a lot of time before I started coding, and like I kind of had an idea, but like, yeah, certain like lines just took me too long.
Yeah. And I think, yeah, you did take a lot of time before you started coding, and that's also like you can figure out a solution faster. But I would say something like, okay, I'm at index I, that's like one indexed. I need to get to index J. And in that permutation, I know where that is. J is just like where that number is. So I need to get to that number. And then I just need to figure out like the what's it called? The whatever, dividing like the bigger by the smaller. And this needs to be a power of 2. How do I do this? And then I would think about this before even coding anything. So I'd be like,
Hmm.
okay, I need to, like, how do I figure out if something's a power of 2? And then how do I divide these things and whatever? If you can't think of that, then I'd go for something else, maybe a heap, or just brute force make all the indices or something. Yeah, like
Yeah.
what you could have done. Another way to do it would be like, uh, you can have like a parent index, and then the rest of it would be like that entire group, and you would just check, is my index in that group, or like what group is it in, are they both in that group, right? So for one, you could have like 1, 2, 4, 8, whatever. You could have made these as well, and then the same thing and so on, right? So this would be
Hmm.
another way. And then like for 4, you just check, oh, it's in 1, so it's in here, and 1 is also in 1, so it's in here. So you basically just check like, are your, this would be like a set, and then you just check like, are both indices in the same, do they have the same parent? Something like that. But whatever you
Hmm.
pick, like, there's a
Hmm.
bunch of ways to do it. You need to be able to do it reasonably quickly.
Yeah. Yeah,
So,
that makes sense.
and that's why I
Yeah.
would plan it out, because when I planned it out, I might be like, oh man, this thing that I'm thinking of before I even coded, this is going to be kind of hard. So I'm going to pivot a little bit into like whatever other thing. Um,
Hmm.
and
Yeah, that
and yeah,
makes
you could
sense.
have also like, I guess, sort of brute forced, or done the heap or something else. Like I guess it wouldn't be like, like I think if you would have come up with a heap or an n log n, that would be fine. Um, but whatever you pick, I think the key thing, or one of the most important things to these things, is you need a solution that's like not ridiculously hard or hard for you to implement, whatever that is,
Hmm.
because you just don't have like 30 minutes to. So like I think I did a mock with another guy yesterday or 2 days ago, where we did a DP problem, and it was like 2 or 3 DDP. And he was trying to go for like the most, like, I'll do bottom up and I'll do all these optimizations, and then he just got stuck coding like 2 lines forever. Um, so you need
Hmm.
something that's like practical, that you can actually like get done very quickly. Um,
Yeah. Yeah, I think like,
yeah.
yeah, honestly, for this, I for the first one, I definitely just need more reps, and
Hmm.
I mean, yeah, for the second one, like, yeah, I had a bug here, but I think I was a
And I
lot
think
more
I
comfortable with
think
like
it's pretty.
implementation.
I think it's pretty common, and I think this happens a lot, where I just take something that's not quite like a neat code problem, and people are just so used to like bucketing all their stuff, and like, okay, what bucket is it in? What thing do I use? If I just make like one tiny difference, they just like get stuck.
Yeah.
So that's the danger of doing that, I guess. Is
Okay.
like, you basically, if it's not in the bucket that you studied, you just don't know what to do, so like,
Yeah.
so what I would say for these kinds of problems is like, really learn to problem solve, and like get better at problem solving skills, instead of like, I mean, I don't know if that's you, but also I guess with like AI and stuff, people are just generally worse at coding and like coding interviews, me
Hmm.
included, because like you might not do a lot. So
Yeah.
that's also pretty common. But yeah, I would say like, you really want to make sure your problem solving skills are the things that improve. So I can ask you something that you haven't seen, and you can really like think it through. And I think
Yeah,
you
that
did
makes
do
sense.
like an okay job, but definitely like too slow to, yeah, too slow to like figure it out, too slow to code the parts that were like important, and things like that. So
Yeah.
you basically do like everything you did, just do it like twice as fast.
Yeah.
I
Yeah,
know
that
it's like
makes
easy
sense.
to say, I guess, but
No,
yeah.
yeah, yeah. Yeah.
And basically at like, I don't know, like top companies and stuff, like you just don't, like, they expect you to get stuff done quicker,
Yeah.
in these interviews. Like you can't just be stuck forever, because you just won't have time.
Yeah.
So
So would you say this first one is like a math question? Like, does it fall into that bucket?
I mean, not really, like, it's math, but it's like you don't need any math. It's just like times
Yeah.
two.
Yeah.
That's it.
Yeah.
Like the brute force. So like I think if you can come up that like the difference is a power of two or whatever, sure, it's a little bit more mathy. But it's like to recognize that like one, two, four, and you even said that, right? You were like, I know that like I can swap these two, and then I could swap these two. So you kind of like you basically just need to recognize they're all part of the same group, and
Yeah.
that's it. So I don't think so. I think if you think multiplying by two is a math question, then like I don't know, like I
Yeah. Yeah.
guess. But yeah, there's nothing like this is math that you're expected to know. It's not anything like ridiculous. If you can't
Yeah.
multiply by two, then I guess you got bigger problems. So yeah,
Yeah. True.
yeah,
Yeah.
um,
Okay.
yeah. And from some of the stuff I've seen, people get asked for, like big companies, like there was way more math than this. And it wasn't like, especially I think for like Google or some other stuff, I think they ask very nuanced stuff. So you can get asked
Yeah.
whatever you want, but I've seen some stuff that was like, how are you supposed to know this if you're going for SWE? So
Like what?
I don't think I could share the exact thing, but it was basically like way more math, like probability or whatever. And
Mm.
the guy had to get a lot of hints, and like it was like he definitely hasn't seen it before, and it's like it's basically like I said, the same kind of similar thing as this. Like I'm going to give you something you haven't seen. There's math involved. I'm going to give you hints. Do you have the problem solving and intuition to figure it out? Like there's not insane math, but it's like way harder than this for sure.
Gotcha.
Yeah, I don't want to give exact stuff because I'm not supposed to share any of that. So yeah.
Yeah, you're good.
Okay.
All right, I just have one other question.
Uh huh.
So when I'm like, say I'm like practicing on LeetCode and stuff, right?
Uh huh.
I've heard some people say like, if you're prepping, um, like getting stuck on a problem for a while is like not worth it, or like as soon as you get stuck, look at the answer and like try to
Mm-hmm.
figure it out, or the other scenarios like, oh, use hints one by one.
Mm-hmm.
What do you think is like the best method for
So
building
I don't have
that
like a
improvement?
golden answer, but I would say for you, you were definitely making progress like the whole time, right? You weren't like stuck. You were making
Yeah,
progress, but it was slow. So in
yeah,
that case, I would recommend just powering through and getting it, because I felt like if you had another 15 minutes, like you'd get it eventually. Same thing for
yeah,
the first one. If you had a little bit more time, if you didn't have to talk, that's another thing, right? You were like, I have to think and I have to talk, and I want to talk, so now I like think worse, and like that's
yeah,
also a really common thing is like people don't really talk while they code. So
yeah.
it's very hard for them. So like maybe if you did this with no talking, you do a lot better because you like
Mhm.
and so. But I would say if you're making decent progress, I would just not look at anything. If you stare at the wall for 10 minutes and you're not getting anywhere, then get a hint or something. So I
Yeah.
start looking stuff up as soon as I'm making no progress, or as soon as I start making a solution. I'm like, there's literally no way in hell it can be this because I like, this would be insane if this was asked. It's like I think that's another good hint. Is someone just I did an interview with them, and then they said like, oh, it's going to be this like math. I think they said like inclusion exclusion or something. I was like, dude, if you get asked inclusion exclusion for like a sweet interview, like there's no way,
Yeah.
or some other mathy type thing. It's like super
Yeah.
rare. So if that's the first thing you think of, you're probably just going in the wrong direction. So those are the two areas where I tend to get hints. Is like if I start coding and I'm like, I just think I'm completely in the wrong direction, or I'm like staring at the wall for 10 minutes.
Okay.
So I think the way you were going, I would recommend finishing and then look at the solution. And usually there's like some things you could have done better. So for example, maybe for the second one, you wouldn't recognize that you could put a one into a zero. You would just move one at a time. And then
Mhm.
you'd still it would still work. Like I think you said there's like a finite number of states you can cache. It would be more complicated for sure, but it would still work.
Yeah.
And then you look at the solution, you're like, oh, I could have simplified this thing. Oh, I could have simplified this thing. And I think that's like a really good skill to have, is like take a hard problem. And so I think the second was like a hard, but it was like an easier hard.
Mhm.
And take a hard problem and make it like there's a bunch of solutions, and a lot of them are way easier. So the stuff that I was saying where like backtrack and put stuff into stuff right away would have been way easier than yours. So a really important sweet like skill is like, how do I make not only make a solution that works, but one that's like practical, easy, makes sense, easy to debug, easy to code, that type of thing.
Yeah.
So
Yeah.
so that's like a good skill to have. And I think
That's
that's also just valuable on the job, because like you can't just write code that works. You need code that's like, extendable, maintainable, like readable. You can't just write a bunch of crap that's like, oh yeah, it'll work. It's just like no one can understand what the hell's going on. So
Mhm.
yeah.
Okay.
So does that make sense?
Yeah, yeah, yeah. Yeah, that makes a lot of sense.
Okay, cool. All right. Anything else?
I think that's it. Yeah.
All right, cool. Well, best of luck.
Yeah, thanks so much for taking the time.
Yep, see ya.